In this video, we'll be looking at the Pythagorean Theorem and exploring some of the applications of it. But first, a definition. The Pythagorean Theorem is the sum, it says the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. You may have seen it written before as a squared plus b squared equals c squared. That's where a and b are the two legs of the triangle and c is the hypotenuse. So let's take a look at our first triangle. We're saying that we're looking for the hypotenuse. Remember, the hypotenuse is the longest side of a right triangle, the one opposite the 90-degree angle. And all we're saying here is that 24 squared plus 18 squared equals, we'll call it c squared, which is the hypotenuse. So 24 squared, or 24 times 24, is 576. And 18 squared, or 18 times 18, is 324. 324 plus 576 is 900, which equals c squared. So all we need to do now is going to be to take the square root of both sides. Well, the square root of 900, square root of 9 is 3, square root of 100 is 10. So in this case, we're saying that c equals 30. So the missing side right here is 30. Fairly simple. Now, of course, we can apply it slightly in reverse as well. In this problem, we already know the hypotenuse. What we're looking for is one of the other legs. But again, the same thing applies. We're saying that, let's just call this a. We're saying that a squared plus 10 squared, which is 100, equals 26 squared. 26 squared is 676. Okay? Subtract 100 from either side, and we're saying that a squared equals 770. Oh, excuse me, not 776. It equals 576. So what is the square root of 576? Well, we're going to need to work that out. It's kind of a big number. It's not one of the ones I have memorized. So what's the best way to look at it? Well, 576 is definitely an even number. And well, let's just try some things. How about the number 6? See if that goes into 576. 57, 6 goes into 57 9 times, that's 54. And 6 goes into 36 96 times. Excuse me, 6 times. Let's try 6 again, see what happens. We're going into 96. 6 goes into 9, well, just the one time. And 6 goes into 36 6 times. So we already know that the number 6 goes in there twice, and apparently it's 6 times 16. Well, what's 16? We recognize that as a perfect square of 4, right? So what we're saying is 4 times 6, or 24, looks like it would be the square root of 576. And it turns out we're right. So the missing side is again 24. The Pythagorean theorem can also be applied on the coordinate plane. This time, to find the distance, we need to look at the ordered pairs. This ordered pair is -5, 4. This ordered pair here is -5, -3. And finally, this ordered pair is +5, -3. Now, the lengths of the sides is simply the distance between each of these ordered pairs. Now, one way to look at that is we can look at the y values here. It goes from 4 to -3. The difference between the two, 4 minus -3 being 7, would give us that length. Or another way to do it would be to simply, in this case, count the squares. 1, 2, 3, 4, 5, 6, 7 squares. No matter how you look at it, we know that the length of this side is going to be 7. And we can use the same approach here. We know that this one goes from -5, -3, all the way over to +5, -3. So the distance in this case is 10. We can do it by subtracting or by counting the squares. And the side we're looking for is the hypotenuse. So we're saying that 7 squared, or 49, plus 10 squared, or 100, equals c squared, which is the hypotenuse. Well, when you add these two together, we get 149 equals c squared. Take the square root of both sides. So we're saying that the length of the hypotenuse is the square root of 149. Can we simplify that any? Well, let's think about our perfect squares. Does the number 4 go into that? No, it won't, because it's not even. Well, the next perfect square is 9. Does the number 9 go into that? Remember, if 9 goes into it, the sum of all the digits has to be something divisible by 9. 9 plus 4 plus 1, that's 15. 15 is not divisible by 9, so that won't work. 4 squared, that's 16, but we already know 4 won't go into it, so there's no point in looking at it. 5 won't go into it, because it doesn't end with a 5 or a 0. We know 6 won't go into it because, again, it's not even. 7's a possibility. We can always check and see. But 7 goes into 14 exactly 2 times, which leaves us with 9. 7 doesn't go into 9 evenly. 8, it's not even. 9, well, we already checked 9, so 81's not going to work either. So yeah, I think we're pretty safe in saying that the square root of 149 is about as simplified as we can get without using a calculator to get a more precise answer. And finally, let's look at one more. This time I moved the triangle way up there, but we're going to look at the lengths of the sides. We can count the squares, 1, 2, 3, 4 squares. See that this is 4 and this is 4. We're looking for the missing side. Well, 4 squared is 16, plus another 4 squared is another 16, and that is the hypotenuse squared. So we're saying that 32 equals c squared. Take the square root of both sides, and we're saying that the square root of 32 is the length of the hypotenuse. Now this time we can work with it a little bit because we know that 32 is 16 times 2. And the square root of 16 is 4. So we can say simply that 4 times the square root of 2 is the simplified version of the length for C, the hypotenuse. And those are some ways you can apply the Pythagorean theorem to a few triangles.